this. What I have for today, we'll spend time on homework. I do have an optional worksheet for in class, but then there's also a homework worksheet. Some students like to have the extra practice, as I just mentioned. Okay, so let's pick back up where we find the slope of the line tangent to y equals sine to the fifth x. I know I saw a few of you at bonus. My first recommendation whenever you see sine or cosine or tan, any of the trig functions, rewrite it. Rewrite it as sine x to the fifth. It makes it much more clear what's outside and what's inside. So the outside is the fifth power and the inside is the sine. Okay, so the slope, meaning the derivative, right? Okay, so outside, the 5 goes to the front. Keep the inside the same. Take 1 away from the power. And then this is the part everyone forgets, times the derivative of the inside. So that's going to be times cosine.
And then if it was like sine of x plus 1, then would you do like x?
The derivative of x plus 1, which would just be 1. But if there was a sine of 2x, then you'd have to multiply.
Okay, cool.
Okay? All right. Now, what are we trying to do? We're trying to evaluate it when x equals pi over 3. So y prime pi over 3. I'll just leave it the way it is. So sine of pi over 3 to the fourth times cosine of pi over 3. I was just helping some pre-calc honor students with this stuff. Remember all that unit circle? Yeah. Okay.
Keep going, right?
Yeah, we're going to simplify this. We can't leave it like this. We do have to evaluate trig values. Okay, pi over 3 sine. Good. Root 3 over 2. Did somebody say something different? Okay. Okay, so if sine is root 3 over 2, then cosine is 1/2. Good. That. That's what you're going to say. Okay. You really just need to, you should know the unit circle. There are problems like this where you need to be able to simplify by hand. But you don't have to do like secant of 27 pi over 4. You're not going to have that. You'll have like things in the first quadrant, maybe second quadrant. Okay, 5 times, well, root 3 to the fourth. 9? Right? Because cosine of pi over 3 is 1/2.
Oh, wait, so then...
And then 2 to the fourth. Sine of pi over 3 is root 3 over 4, and then I want to raise that to the fourth power. So since root 3 squared is 3, root 3 to the fourth would be 9. And then just multiply. It's not a very pretty answer, but... Right? Just make sure it's reduced. It is. Okay. All good, Sam?
Yeah, no, I just need your next.
Oh, okay. All right, that's all we had to do for that. It didn't ask for the tangent line, it just asked for the slope. Okay, show that the slope of every tangent line to this curve, 1 over 1 minus 2x to the third, is positive. Okay. Slope means got to find the derivative. Now, before I do that, I'm going to just rewrite this as a negative exponent. Just makes it a little easier when I'm evaluating. Do you have to do that? No, you can still do quotient rule. It'll work. It's the same thing. I think there was one on the homework where it was better to rewrite it with a negative exponent. Yes, Ryan.
So instead of doing quotient rule, you can just always bring the bottom to the top instead of the negative.
Yep.
Okay, that's good.
Yeah, it'll work every time. Okay, negative 3, 1 minus 2x, take 1 away, becomes negative 4. Don't forget, this is the part everyone forgets. Chain rule. Multiply by 2. Okay, so y prime, how would we rewrite this?
6. 1 minus 2x to the fourth, negative 4.
Okay, I'm just going to put that negative 4 power as a positive 4 in the denominator. Now, this is representing the slope of my tangent line, right? For any value of x. So what are we trying to say? We want to show that it's positive. Okay. Well, the numerator's positive, isn't it? So 6 is greater than 0, and 1 minus 2x to the fourth is greater than 0, right? Because it's got an even power. Therefore, y prime has to be greater than 0. Yes, Ryan.
If I plugged in 1 though to the, oh wait, never mind.
The slope.
Would it be?
No, I'm talking, well, my question was, if I plug 1 into x and the 1 minus 2x, it come up to -1. I forgot the-
Oh, yeah.
Would this be greater than or equal to? Because couldn't you technically make it equal?
Yeah, you could say, the problem is we don't want it to be equal to 0 because there's an asymptote there.
Oh.
We want positive, yeah.
Sometimes it would put the negative x.
I know, I don't like that. I prefer to always. Okay. Last thing. Oh, yes.
So how did you get the 9 over it? I'm still like confused on.
Which one?
So for the root 3 and then for the times 1/2.
We'll do root 3 times root 3 times root 3 times root 3.
Oh.
Right?
Yeah.
Okay. You had a problem like this in the book for homework?
Yeah.
Okay.
Hey, Shelly.
Yes. Okay.
It was. I hated this problem.
Problem number 4.
Oh.
Yeah, you had one like this. Okay. So what is this basically saying? This is doing the product rule. Okay. So that would just be f prime, and it's going to be at 1. So I'm just going to write it out. F prime of 1 times g of 1 plus f of 1 times g prime of 1. Okay. You often have ones like these in like a multiple choice question on the AP. So they'll give you like a big table of values. Most of them you don't even use. It's just, now we want to look at the table. Did you have a question, Andrew?
No.
Okay, so if we do f prime of 1, right, here's 1. So that's 5/3. Oh, I didn't give you very much room here, did I? Sorry about that. 5/3. And then g of 1. What's g of 1? 1. Go, it appears 1. Okay,
Wow.
plus f of 1, so that's 1/3, times g prime of 1, which is 2/3. So that gives us what? 5/3 plus 2/9. Oh, I had to get 17 over 9.
Oh.
Yeah, right? Because then it would be 15/9. 15/9 for the first one, right? Common denominators. The final answer is 17.
Oh.
I was saying this, 15/9 plus 2/9.
Oh, okay.
Yeah, sorry. Okay, what is B showing? Quotient rule. Okay, so it's going to be, and this time is at x equals 2. So it's going to be low, D high, take high, D low.
Wait, what is D? Oh, derivative.
Yeah, D is representing derivative. So when I say this, low, D high, take high, D low, cross the line and square the low. Sure. Okay. Because that's something I would do. That's something I would do with my spare time. Okay. Okay. F of 2 is what? Sorry, I really did not give you much space. So we have, I'm going to do it up here. So 1 times g prime of 2? Negative 4, good, minus g of 2, negative 1/2, f prime of 2, oh, more fractions, 1/4, and then f of 2 squared. Where's f of 2? 1, oh, good, so it's just over 1. Okay, what do we have? Negative 4 plus 1/8,
Yeah.
which? Negative 4 plus an 8. Sure. Negative 3 and 7/8. It's fine.
Is that the answer?
Yeah. It's correct. It's fine. Okay. Derivative of the square root of f of x. Okay, so we have a composition of functions. What's the square root? A power of 1/2. So I'll get 1/2 and then f of 3 to the negative 1/2 times f prime of 3. Do you see where I'm going with this with the chain rule? Now, 1/2, keep the inside the same. I'm just plugging in 3 right away. We're okay with that. To the negative 1/2, because you have 1/2 and then subtract 1.
Is this the chain rule?
This is chain rule.
So then that equals the f of prime of 3.
Yeah.
Why isn't it the other way around?
Wait.
Okay,
Oh,
so
never mind. I get it. Never mind. You're right.
rewrite it as f of x to the 1/2 power. Okay,
But then f prime of 3.
okay, so,
That's f, wait, that's already f prime of 3, right? Or is it not?
yeah. Well, what's f of 3? 1. So 1 to the negative 1/2 is still just going to be 1.
Oh.
Do you see it?
So yeah, because Griffin's
I would say Eagles had this in my life.
You also have it on the paper in front of you. What are you talking about? This? The work?
Yeah, no, that's what I'm talking about.
That's what you're talking about. Okay. What's f prime of 3?
0.
So the whole thing is 0. Okay. D is chain rule. So it's going to be f prime of g of 4 times g prime of 4. Derivative of the outside, keep the inside the same, times the derivative of the inside. This time I'm not putting x, I'm going to put in 4. Okay, so f prime, what is g of 4? 1. What's g prime of 4? Negative 1/3. Now, because this was a composition of functions, I had to work from the inside out with this first part. So g of 4 was 1, but then what's f prime of 1? 5/3. So I have 5/3 times negative 1/3 to make it negative 5/9. Okay. Are we okay with that? Kind of? Okay, this one below, let me just use a different, g prime of 4.
So where did the G of 4 go?
It was 1,
Before it had the value.
had a value,
Oh, the F prime of
and then you take the f prime of 1.
Oh, right.
Oh,
Is that, okay, with this next one, you see where the 3 is? That's kind of like sine to the third or cosine. So what we want to think about is this is really g of x to the third power. Okay, so what's my outside, what's the inside? The outside is the power, the third power. So we're going to move 3 to the front. G of, this time I'm got 2 to the second power, right? Move the 3 to the front, keep the inside the same, take 1 away. Don't forget that next step for chain rule times the g prime of 2. Okay, and what's that give us? What is it? 3 negative 1/2 squared and negative 4? Negative 3? Okay. You did not get negative 3. Did you get?
No, I definitely don't get that.
You didn't get this.
No, I got that.
Okay, well, what's negative 1/2 squared? Positive 1/4? What's positive 1/4 times negative 4? Negative 1? 3 times negative 1? Okay, last one here, and then we'll take a look at the homework. Okay, so derivative, this is also chain rule, but now the outside is g. So it's g prime of f of 2 times f prime of 2. Yeah? Good. And what's, so f of 2 is 1? Oh, f of 2, it's 1. So I have to figure out what f of 2 is. Now I do g prime of 1 times a 4th. So what's g prime of 1? 2/3? Sorry. 2/3?
Yeah.
Times 1/4? Okay. That was. Well, because you had practice with it. It's.